This question is about different types of electromagnetic radiation. Which type of radiation can cause free electrons to oscillate in an electrical circuit? The answer is B, radio waves. That is how they are detected by the antenna. The human eye can detect a range of wavelengths from violet at about 400 Newton meters to red at about 700 Newton meters. Figure 8 shows the relative sensitivity of the human eye to different wavelengths when inside a dark cave. Use the information in Figure 8 to determine the wavelength to which the eye is most sensitive inside the cave. So here we're looking for this peak point. So if I bring that line down, I've got there approximately 510. Now here, any number between 502 to 510 would have been accepted. Calculate the frequency to which this wavelength corresponds. Give the units. So the speed of light in air is 3 times 10 to the 8 meters per second. So we've got our wave speed equals frequency times wavelength. So we need to find frequency. So we're going to do the speed divided by the wavelength. So that 3 times 10 to the power of 8 is the speed, divided by the frequency of 510 nanometers. So obviously that is in nanometers. So I need to make sure that I am writing 510 times 10 to the power of minus 9. 3 times 10 to the 8 there. So if I put that into my calculator, I'm going to get here 5.98 times 10 to the power of 14, and the unit for frequency is Hz, hertz. Part 3. Using information from Figure 8 to describe how well the eye detects different colours of the visible spectrum inside the cave. So I need to mention colours here to get my 3 marks. So I need to mention the most sensitive colour, or the colour that our eyes are most sensitive to, I should say. So that is in the middle of the spectrum. Remember, we've got red, orange, yellow, green, blue, indigo, violet as our colour spectrum. So in approximately the middle of the spectrum, green is the colour that our eyes are most sensitive to in the cave. So here you could mention about 500 nanometers, but the question does say colours, so we'll focus on those. So red in the question over here is about 700 Newton meters. So we cannot detect red, or we can say that is the lowest sensitivity. For 700 it's over here, and we cannot even detect that from our curve. Cannot detect red, lowest sensitivity in the cave. And then violet is about 400 Newton meters. And cannot detect violet very well in the cave. So we've said what we're most sensitive to for a mark, what we're least sensitive to for our second mark, and then we've said about the other end of the spectrum, violet, which is slightly sensitive but still very, very weakly detected compared to the middle of the spectrum. There's our 3 marks. So part C says, Figure 9 shows the relative sensitivity inside the cave of an insect eye and a human eye. So using information from Figure 9, compare the relative sensitivities inside the cave of the insect eye with the human eye. So comparing, I need to say some similarities and some differences. Okay, so similarities. Both peak in sensitivity in the mid-range, or the middle wavelength. Middle wavelength range. However, the peak is actually different, isn't it? Peak for insect is about 540 nanometers. Humans is about 510 nanometers. Also different, the insect has a larger range overall. The insect can detect a much greater range than the human eye. So it's 4 marks. I want to try and make, say, at least 4 separate points. So I could say also that the insect can detect below 400 nanometers, but human eye can't. There are lots more things you could say. You could say for another similarity that both are insensitive at longer wavelengths. So the longer the wavelength over here, both of them have a decrease in sensitivity. But you could say for a similarity that they both decrease at longer wavelength. I think I just said that. But you could also say that the insect is much better at detecting the shorter wavelengths. So I've said that here with a number, but you can say the insect can detect shorter wavelengths than humans. It doesn't have to be as specific as this. You could mention actual numbers, as I have done, or you could mention colours. It would absolutely be fine to say that both humans and insects are insensitive at the red end. Or you could say the numbers.